Hello and welcome to 4-5. Today we're going to be talking about equivalent fractions. And I just thought this was a really good representation of what equivalent fractions are. They're fractions with the same value. You can see these all take up the same amount of space, right? This is where they all are. It's just this was cut into one piece, this was cut into two pieces, and this was cut into four pieces. Okay, so it's just kind of like my analogy that I always give about the pizza. If I cut my pizza into 4 slices or 8 slices or 16 slices, it's still one pizza. It's just I'm cutting it into smaller pieces. So if I eat one piece, if I cut it into 2 pieces, I'd be eating half the pizza. If I cut the pizza into 10 pieces and I eat 5 pieces, I'm still eating half the pizza. I'm still eating the same amount, I'm just eating more pieces. Okay, so we're going to kind of dig into this a little bit today. Alright, so here we have our vocabulary words. Again, an equivalent fraction is any fraction that represents the same value. Now, how we find that is if I take this by example. I have 1/3. I have the bar, it's cut into 3 equal slices. I'm going to eat one of them. I'm going to eat 1/3 of the total bar. Now, if I want to, instead of cutting it into 3 pieces, I'm going to cut it into 6. I could multiply the numerator and denominator by 2. So then I would get 2/6, which is what this equivalent fraction is here. Now, and if I go back to my original 1/3, I could go use the 2/6 too, but we'll just go back to 1/3. And I could multiply by 4, and I would get 4/12. Okay, so to find those equivalent fractions, we need to multiply or divide the numerator and denominator by the same number. And then we have another vocabulary word called simplest form, and that's when the greatest common factor of the numerator and the denominator is just 1. Okay, so let's look into some problems here. So here it says find 2 equivalent fractions for 6/8. So this picture right here shows 6/8. Right now I think it's a little bit easier to go back over to the right hand side and say, okay, well, if I took my 6/8 and I know I can divide them both by 2, I would get 3/4. Okay, so if I divide my 6/8 divided by the numerator and the denominator by 2, I would get 3/4, which is shown in this part right here. Now let's say I took that 3/4 and I multiplied by 3 multiplied by 3, I would get 9/12. So if you get a question that says find 2 equivalent fractions for 6/8, the answer would be 9/12 or 3/4. Now you could also do something crazy and say I'm going to multiply them both by 100. Okay, so there's many options. You could pick whatever number under the sun as long as it's a whole number to multiply by. So you could also say 600 over 800 is an equivalent fraction. Right? I mean, you can pick any number as long as you're doing it to both multiplying or dividing to both the numerator and denominator. Alright, so now we have to find the missing number that makes the fractions equivalent. So really we're looking at a relationship here. We're looking at what did I do to 3 to make it an 18. And I know I'm going to need to multiply or divide. It's none of this adding and subtracting business anymore. Now we're multiplying and dividing. Okay, so I know I'm getting bigger, so I'm going to multiply. 3 times what gives me 18? 3 times 6. So if I'm going to multiply the denominator by 6, I'm going to need to multiply the numerator by 6. And 2 times 6 is 12. So 12/18 would be my equivalent fraction. Okay, so then again here, I'm going to look at my 2 numbers that I have to go from 70 to 7. I know I'm going to need to divide because my number is getting smaller. And I also know that 70 divided by 10 is 7. So that means I need to divide 100 by 10, and that will give me an answer of 10. So my answer would be 7/10 to get an equivalent fraction. Alright, so now we need to talk about simplest form, and we talked about, that the GCF has to be 1. Okay, so if I look at 18 and I look at 24 and I GCF them, I would get 3 times 6, 6 would be 2 times 3. 24, I could do 3 times 8. 4 times 2. 2 and 2. So the greatest common factor has to be 1, but if I'm looking at these, I see they both have a 3, and they both have a 2. So I know it's not simplest form. Okay, so I know I can divide both by 3 times 2, the GCF, which is 6. So if I divided 18 by 6, I would get 3. If I divided 24 by 6, I would get 4. So I know that the simplest form is 3/4. Another way to look at it is you want them to be, one of them probably is going to be a prime number. Well, it's going to be a prime number when you simplify it. Because if you have two numbers that can be anything else with it, it's not going to work. And also remember, you have to be able to do it to both the numerator and denominator. So another way I could look at 18/24 is I could say, well, I know I can divide them both by 2. So then I would get 9/12. I say, hey, look at that. I can divide them both by 3. Okay, so 9 divided by 3 equals 3. 12 divided by 3 equals 4. So you're getting to the same answer. It's just you have to do a couple steps. Whereas we found out that the greatest common factor was 6. Didn't really take me that long. And then I know I can divide them both by 6 and go. Now some of you might see that. You don't have to do this greatest common factor. You just want to make sure you simplify them as much as possible so that you cannot take any number out of both of them anymore. Okay, now let's look at this number 8/9. Now, here, I guess it doesn't have to be a prime number because here we go. 8 and 9 are both not prime numbers, but are there any numbers that can be that they are both divisible by? 8's divisible by 2, 4, 8, and 1. None of those go into 9. 8 is already in its simplest form. So for that one, we'll just write simplified. Alrighty. Alright, and that is all that I have for you today. Now we'll get some more practice tomorrow, and I hope you took really good notes so that you can have them to study for your test. And I will see you tomorrow. Thank you for watching.